Hello, dear viewers. Today I going to explain and consider some engineering of electrical problems that follow from physics laws, basic laws. And first law is Kirchhoff's law. Sorry, Coulomb's law. Coulomb's law is law about power. Power called Coulomb power. Coulomb power designates by letter F, which equals like multiplication of two charges, one charge, two charge, and the numerator divided by 4 pi multiplied by times electrical conductance or electric conductant or electrical permittivity as right, or just electrical constant, and times distance between charges in square, because all power decreases dependent from distance in power as 2. Okay, later F, uh, dimension dimension of uh, power is Newton. Newton unit called as Newton. Okay, and what the next? Next is describe electrical constant. Electrical constant dimension is epsilon with index 0. It is a conductivity in vacuum. Sounds like farads divided by meter. Like is described in where? Described in international dimension system, which physic electric physical electrical mechanical etc items subscribes as in subscribed in electrical in dimensional system. Aha. The next we will consider electrical field tension, which dimension of which dimension is volts divided by meter. It is multiplication of two charges, one charge times second charge. They are charged between any two charge. This tension, and in the denominator is two constants. First constant is constant as we know earlier, is constant in vacuum, and second constant is item constant, is specific conductivity, permittivity, electrical permittivity, not conductivity. Exactly is permittivity in specific environment. Okay, and if we surround any surface which described a dimension some around our second charge, sorry, in vain pictured here, painted. No, I shouldn't do it, and it's my mistake. And the next we can describe as integral around surface uh, is electrical field tangent as integral uh, by surface is ds. S is surface. If we described our charges are as 2 points, 2 and 1, and distance of L between them. Sorry, it paint application works very odd, and we can describe as this as letter L, and this law is first Maxwell law. First Maxwell law is a law of Gauss, and it is full charge, full charge divided by constants multiplication, constants multiplication, and tangent or not tangent, voltage is exactly equals potential of first point minus potential in the second point, and it is and it equals as the integral uh, of electrical tension by dl. dl dl is differential of this distance of L. Okay, and another for voltage formula we can explain as electrical field tangent equals like gradient of nabla times phi. Phi is a potential. It is another form of describes electrical field tension. And this is Gauss equation is a second formula of Maxwell. And second and first formula of Maxwell we can explain as Faraday's law for electrical units. For magnetic units exists second two formula, and second formula for electrical item is sounds like integral of electrical field tension dl equals from magnetic fields as d this letter psi is tangent is flux linkage. Sorry for my swinging language tone, no, not language, it is tone. And today we have the formula of electrical inductivity. It connects magnetic units with electrical units, and electrical units electrical point is tangent of electrical fields, and magnetic points is uh, linkage of fluxes. Fluxes may be several, not one. It means not one. And we have uh, linkage, linkage of fluxes may be described as one flux plus second flux plus etc plus n flux. Okay, and we have linkage and electrical point of Maxwell's law, second Maxwell law as electrical form, as integral form in addition. And the magnetic magnetics we have of magnetics equations of Maxwell's law we can explain describe sorry as integral of magnetic field tangent uh, point times dl. It along the integration it the integration um, makes made along contour of L and equals full current full current along this contour. Full is F. Okay, and fourth Maxwell equation is about magnetic field tangent 2 in integral form. It is like integral uh, around surface along surface, not around, of h d sorry it applications full sorry fix it. I must fix it. And ds ds around surface integral equals what do you think is equals zero. Zero. And we have the four laws of Maxwell in integral form. First, second, third, and fourth. In details, Faraday's law, we know it is electrical induction law. It describes as electrical field tens arises along contour or mesh electrical wire closed to loop if the loop cross sections magnetic flux or maybe not one contour. Maybe it won't exist from several contours as in coil. Okay, and it is low like this. And third law is law as magnetic field arises around any part of uh, current conductor like this. We have current along the conductor and we have uh, like this magnetic field. We can describe the field as B. B is measured as Tesla. Tesla units. TL. TL. Okay. Okay. And it is vector unit. Or in Russian it called magnetic induction. Magnetic induction B. And we can describe it as B equals uh, magnetic constants multiplication basic constant times specific constant uh, times magnetic field tense, and we have B magnetic inductance. And if we magnetic inductance times for square, which cross section square of cross section of uh, across magnetic field, it equals flux. Flux. Flux is magnetic current, like seems like magnetic current. Okay, and they are in integral form, uh, Faraday laws. Okay, the next we have here. What we have here? The next Faraday laws in differential forms. They are seems like rotor or rotor H equals uh, electrical conductivity times electrical tension plus electrical derivative of electrical displacement. It is a first law from Maxwell Laws about magnetic units of electrical magnetics items. Okay, and the electrical is which is Faraday's law equals rho called as rho E equals minus dB for dt, and divergence. Oh, sorry, it's wrong. Divergence of B in this time equals 0. And the last law is Gauss law. Gauss law describes as divergence of E electrical tense equals the density of charge surrounded by surface divided by constants. Okay, there are four laws of Maxwell in differential forms, and these equations they are Maxwell equations in integral forms. I hope you understand how I could do this, and goodbye for today.